It's the other thing that's happened over the last 25 years. I don't think it's viable to be an engineer anymore who just takes a ticket, codes it. You have to be understanding the user, the product side. You have to be contributing and being creative, because otherwise, how much more use are you than an AI agent? Most of that AI generated code is not particularly ready for prime time at the moment anyway. Everybody is having the realization that the hard part is to get it to go from something to something good. It's like an iceberg, right? The stuff below the water that's not visible is the most important part. I think designing good APIs has become a really essential skill, and it's now a company-defining thing, whether your APIs are well-defined. We either are going to get to a point where software is really a commodity and you throw it away all the time, or we're going to continue in the world that we live in today, which is actually the more complex a system gets, the more difficult it is to replace it. You'll end up with lots of legacy systems sort of on life support. And the person who can crack how to understand an existing system and have AI recreate it accurately in a better way that's less tech debt, that's going to be a hell of a business.
Welcome to Rewired. This is a Pantrium miniseries where we'll dive deeper into how technology has evolved over the past 25 years and what that transformation means for people and businesses, and especially in this next wave of change driven by AI. And with me today is Meri Williams.
Hi, nice to meet you. I'm Meri Williams. I'm the CTO at Plao. I am the chair of the Lead Dev Conference, and I'm an advisor to a number of companies and sit on some boards.
And I really looked forward to this conversation because, due to your background, you have been through hyper growth and leading tech teams through those, as you mentioned, you're at Plao now, but also just all the work you're doing in coaching CTOs and sharing the dev conference and so on. I feel like you're exposed to so many great things and have been through so many fantastic experiences throughout your career. I'm really looking forward to deep diving into today's topic.
Me too.
And I'm keen to understand a bit about, of course, 25 years of technology, the cultural shift, and when we look at the rise of open source and the developer-led growth to today's AI-driven workflows. And one of the things I wanted to talk about is this concept of what can leaders learn, and especially the technical leaders, from the hacker ethos, building in public and leading without control, and the balance and speed with ethics in the world where everything can be shipped. I wanted to first start up with Meri to ask you, as we're kind of reflecting back and being a bit nostalgic for a second here, 25 years of coding and building in tech. When you think about that, what's the first thing that comes to your mind?
I think the rush of dopamine that you get when your tests pass. So building something, seeing it become real, but that moment where everything passes is like a real spike of enjoyment and satisfaction, I suppose. And that's what I've always associated with coding, is that sense of satisfaction of getting something to exist, getting something to work, getting something to be useful.
Yeah. And I was reading a book about DevRel last year, and it was talking about this concept of, he was the former CTO of Twilio, and he's talking about this concept of the developers being the most creative folks and also the most clever people in the room, and that sometimes others don't let them thrive as much as they should, because they are, to your point, like they're creating so many things in our everyday life. And I think sometimes we forget how powerful engineering and developer teams are.
Yeah, I think it's really easy to treat us like code monkeys, to assume that we have to be told exactly what to do and exactly how to do it. And I think that's the absolute worst way to get a great result out of an engineering team, is to tell people exactly what to do and exactly how to build it. You want them to understand the customer, understand the problem, understand what's possible with the technology, and then bring those things all together into something that might surprise or delight the end user, rather than just ticking the boxes that the spec has been delivered as written.
Absolutely. As we dive in today, I wanted to start with looking into the past and reflect a little bit on that. When we're looking back, almost looking at it as from the playground of thinkers and hackers and idealists and so forth, and building new cool technologies that others have not even thought of. How did that, in your opinion and from your experience and from where you sit, how did that early on kind of created this space and shaped the way that we look at software developers and building products today?
Yeah, so I think it's been a really interesting industry, because it's absolutely an industry of hobbyists. A lot of people who ended up in tech, particularly older than me, my age, we got there because it was our passion, as well as a thing that we chose. We might have chosen to study it or not, but we were excited about it. We were pulling things apart to see how they work. A lot of it used to be called phreaking, right? Where you messed with phone lines and found ways to hack into different phone systems and that kind of thing. And then, you got into the more hacking elements afterwards. And it's had some very positive impact on the industry because people are so passionate. They are so creative and they want to use that creativity to achieve great things. I think it's also had some negative effects. If you can rely on everybody spending every waking hour on coding and learning more about coding and learning more about technology, then you can treat learning and development like it's something that happens in people's spare time rather than something that needs to be part of the job. And that's not always been positive, particularly for anybody with caring responsibilities or interests outside of technology, right? If you just have a broader life than just code, then it's not great if your employer expects that you're going to do all of your development in your own time and not need any support in the workplace. And so I think we've come to a nicer kind of balance these days, I think, where, we appreciate that tech's constantly changing. We have to keep up. We have to stay current, but that requires some time. It's not something that you can rely on people doing on the evenings and the weekends anymore. And I think that that's a positive growing up of the industry for sure.
Yeah. And it actually, I just thought of, as you were saying there too, do you see that Silicon Valley, and when you're looking at the boom of the big tech giants coming to surface and, the Zuckerbergs and the likes, right? Do you see that have also had a negative impact because it felt like, oh, we needed to be like the folks in Silicon Valley, and that's where we had to be, and we had to like work, to your point, at all hours. Do you see also that had a negative impact?
Yes, I think so. And I think it's sadly having a negative impact again now. You've got this 996 thing that's happening where people want people to be working, 9 hours a day, 6 days a week, spend all their time at the job. And I think it's just very short-sighted, right? We know that if just working constantly was the ultimate panacea, then America's productivity metrics would be better than everybody else's, and they're not. Right? I'm not saying that there aren't amazing businesses built in the US. There are, but like actual productivity, countries with more rest and more holidays built in do tend to do better from a productivity point of view and from an economic growth point of view. And so I think that this mindset that you have to be running fast all the time. When I was at Monzo, one of the best things that the CEO would say was building a bank is a marathon, not a sprint. And you need to be resilient. You need to be ready to do this for the next few years, not just the next few weeks. And I think that mindset was a big part of Monzo's success. Tom Blum was very good at making sure that people were there for the long run and were there trying to make a real difference for customers. Making a real difference for customers requires that your company succeeds. Even if you're in it for all the altruistic reasons of wanting to make a difference in the world, you can only do that if the company succeeds and you're commercially viable enough to continue. And so I think that's a perspective that maybe got lost a little bit for a long time because there was just so much free money going around with this zero interest rate era that we were in for quite a long time.
When we're looking back, we're also seeing this concept of moving from closed systems to more collaborative open systems. How are you seeing that shift over time also have influenced the way of technology, like tech leadership, and what it requires for leaders, but also the teams?
I think that it's led to a very interesting cultural phenomenon, which is we firmly believe with code that sunlight disinfects, that more eyes on the code leads to fewer security vulnerabilities. It leads to more secure and more sustainable and more resilient systems. And it's been interesting because that perspective has bled over into some of the more soft skills areas as well. And so you find a lot of engineering teams are the teams that want to have their pay bands transparent. They want to have the pay on the job listing in the first place. They want that clarity and transparency. And this sort of sunlight disinfects mindset has affected much more than just the open source code side of things. It's become a part of the entire way of working. When I was at the Government Digital Service, the team that built Gov.uk, we worked in the open. And that didn't necessarily mean that everything was open source, and properly open sourcing something requires a lot of effort and a lot of intention. But even just the fact that we were governments and we were working in the open and people could see the code and they could examine it and they could try and find a problem, but so could everybody who was trying to protect from problems.
Yeah.
And I think that was super interesting and a very pivotal moment in the UK startup scale-up area. There was this very weird moment when Tim O'Reilly came to visit the GovUK team back in 2012, and I remember him tweeting that the most exciting startup in London right now is in the Cabinet Office. That's very strange. But he was right. It was this fascinating time where that open culture, that ethos of hacking, that desire to bring proper user experience and usability and accessibility to everybody in the country came together in a really beautiful moment where there was some political cover to try these new approaches and to show that it could be done better rather than just saying that it could be done better, which had been the case for a long time.
Yeah. And I think it's so cool that you were behind that scale, the build of that team, right? Of the gov.uk.
Yeah. I was hugely lucky to be a part of it.
It's so cool. Like, I lived in London for 7 years, and it was such a nice, simple, easy way. And it's like, I think most people who are living in the Nordics, because we are very digitalized in our industry and like the governments, and like we have digital IDs and everything, right? But from the UK, as that became a thing, it was so cool. And I wanted to hear, because you were part of that success, looking back and with your experience in that, what would you say was like the biggest takeaway, and what was the biggest thing you wouldn't want to do again?
To be flippant for a moment, cake solves all problems was one of my takeaways. So I realized when I joined the Government Digital Service that there were lots of silos between teams because we were growing so fast. There were just so many new people all the time. And I was living in Newcastle at the time, and I traveled down to London every week and stayed for the week in the capital. And I decided I would make friends with one person in every team, and I would give them the option to choose what I baked each week, team by team. And it meant that I would turn up in the office on a Monday mid-morning, because I was coming from Newcastle. It was about a 3-hour journey, with 2 big bags full of what I had baked that weekend. And the people from each team who were my friends, they all knew there was cake coming. And so by the time I got to the tiny galley kitchen in the office at the time, I had this little row of people behind me, like ducklings following the mother. And I swear you can still see the cake network today in government. Some of the silos that were broken down in that queue for cake in the kitchen. And so it's sort of weird what small things can really shape the culture. So bringing cake every week shaped the culture. We had this sort of need for teams to feel their own sense of identity, but also for teams to collaborate better. And so I had every team choose their own mascot and then got them a plushie toy that represented. So there was a team that was griffins, and there was a team that was a badger, and all sorts of things. And if 2 teams were being annoyingly siloed, I'd book a meeting for their mascots to meet and suggest that some humans should probably come along as well. And so, you know, it's sometimes the smallest, silliest things that make a difference. The badger was for the platform team, the infrastructure team that owned all of our deployments, and it became the badger of deploy. To make sure that people didn't deploy at the same time, you had to have the physical badger with you in order to be able to do a deployment. And it was such a silly thing, but that, you know, the badger of deploy got its own Twitter account, it got hundreds of followers, and some of the fun of that, I think, really shaped the culture of the Government Digital Service. And it's a little weird as a professional to be like, yes, my major contributions were plushy toys and cake. You know, it's not quite what I imagined when I studied computer science that I thought my major achievements would be. But yeah, I think some of those small things that impacted the culture. When gov.uk went live, I baked a huge gov.uk logo, like it was enough cake for 300 people. Wow. That was, our head of content design lent me her kitchen and her stand mixer for the occasion. I suppose the takeaway is sometimes the little things really matter, and sometimes nudging culture in a positive direction can have hugely outsized results.
Yeah.
In terms of the thing I wouldn't do again, we went from 30 to 300 people in 9 months, and I would never do that again.
Wow.
I had 80 direct reports at one point in that journey, 80. So I was doing
Wow.
80 one-to-ones a month at one
And
point.
that's impossible.
It's possible. There's enough hours in the month to do it, but it means that you don't get much else done in working hours if you've got 80 one-to-ones to do a month. And so, yeah, that sort of rapid scaling, which obviously we did with a combination of hiring and partners. We couldn't possibly have hired all of those people in that short time frame. But someone promised the Prime Minister a date. We needed to get it live on time. And so we had this extremely aggressive sort of timeline that we had to meet. But yeah, given the choice, I would never do that sort of 10x in under a year kind of approach ever again. I think I learned a lot about what breaks when you scale that fast.
I wanted to move us into the present, where builders stand today. And when we're looking at open APIs, we touched upon open source a second ago as well. And now with AI tools, how do you see that this day-to-day role of the software developer has changed?
Yeah, it's changed quite a lot. I think you've got a few things happening. You've got product managers and designers and others able to vibe code. So they don't just have to put something together in Figma that looks right. They can put something that does the right thing. It acts correctly as well. Most of that AI generated code is not particularly ready for prime time at the moment anyway. Everybody is having the realization that the hard part isn't getting it to go from nothing to something. The hard part is to get it to go from something to something good.
Yeah.
And something scalable and secure and all of these other aspects, which is kind of the experience that people have as engineers. They start off as junior engineers, they're building whatever's put in front of them. They're very sort of task focused or feature focused, but they don't really understand the broader system and the non-functional requirements and security and accessibility and all of these other things that matter so much. And then as they get to mid-level to senior, they become much, much more aware of those things. And I think that we're in this weird moment where lots of people from other disciplines are like speed running, having that experience of an engineering career of going like, oh, this is like magic. I can go from nothing to something that looks right and seems to work right.
Yeah.
And then you get into the edge cases, and then you get into the weird behaviors under the hood when, you know, there's an unexpected input or whatever else. And so then you got to learn how to test properly. Then you got to learn how to scale properly. And so I think you're having this really interesting phenomenon where a lot of people are getting a lot more savvy about why engineering matters at the same moment that everybody's predicting that engineering is over as a career. And so I think it's very interesting and contradictory that we have this happening at the same moment.
Yeah. Do you think also that have completely not undermined, but people misunderstand what it actually takes to truly develop code?
Yeah, absolutely. And I think people, it's like an iceberg, right? The stuff below the water that's not visible is the most important part. And I think that's the realization people are having. And it's very easy for something to look good enough, but not be good enough. And I think, you know, I'm a little more skeptical end of the spectrum possibly, but I think I'll spend my next 10 years as a CTO cleaning up after tech debt induced by AI. And I think that's probably what's in the cards for me. But I might be wrong. And maybe the tech will improve enough that you can get something that's truly production ready out of these tools. But yeah, I think it's going to be a very interesting few years as we figure that out.
Absolutely. And I think it's interesting. I wanted to get back to what you just said there in terms of you will clean up after the AI code. But I wanted to just, before we go that way, I wanted to hear a little bit more about what you see the role of open source and open APIs have also in today's world, because not everyone have moved to that or may not want to. But how do you see that? And do you see that that's something tech leaders out there and developers really should lean into? What's your take on that?
Yeah, so I think my take's a little different between open source and open APIs. So open source, I think, is the bedrock of the industry now. And we maybe do have some problems about whether industry giants are putting enough money into it. And you want these things to be free and to be voluntary, but some support is needed as well, right? And there's a classic XKCD cartoon about how the entire world and the entire internet at the end of the day is relying on some module that somebody maintains from their bedroom in the middle of nowhere. Yeah. And that's a risk that we're not great at managing. And so I think on open source, it's very much become the standard. It's shown to be in many ways better than being built on proprietary options. We're in a pretty good place in terms of being able to rely on open source. Open APIs, I think, are a different thing. I think a lot of companies are realizing that their capability needs to be exposed not just through a great user interface for a real human to use, but maybe also through an API for computers to use, for AI to use. And I think that's leading to a very different way of thinking than we've had in the past. You have to think now about your product in a human readable form and in a machine readable form, yes, and in an AI interactable form. And those three things are quite difficult to put into one API. But if you have multiple APIs, if you have to maintain three separate things for those three separate use cases, that triples your engineering work. So you end up in this place where you want to design everything to be, that you've got an API that you use internally, that you build your actual interface on top of, and you want to make it accessible to connections with other APIs, other systems and services, but potentially you want to make it open to AI for MCP and similar in the future too. And so I think that's causing some really interesting architectural challenges and problems. You also have to guard against different things for those different use cases, security-wise and so on. And so it's making it quite complex, but not in a bad way, just it's making it much more interesting than it has been for a while. And I think designing good APIs has become a really essential skill. And it used to be something that only mattered to engineering, how well designed your API was. Yeah. I think it's now a company defining thing, whether your APIs are well defined.
Yeah, no, absolutely. I couldn't agree more. I find it myself super fascinating. And one of the things that I have tried to educate myself a little bit on, and now, of course, I can't remember the acronyms, but like when you have your APIs, your developer portal, your tech to interact with another computer, as you said, right? And that could actually create your MVPs and so on. Do you see this as a hype, or do you see there's actually real potential here?
I think there's real potential here, because I think we're moving from a world where you go to a website and look yourself for different hotel rooms and different options for your holiday, to a world where you start to say, hey, I want to spend 2 weeks at the beach within 3 hours of where I live. Find it for me. And I think the MCP era of, how much do you delegate the ability? Do you want that to just find you that holiday, or do you want it to actually buy you and schedule you that holiday and put it in your calendar? And I think how far we'll let AI go on our behalf is going to be an interesting learning experience. I think you don't want to just connect your credit card and trust. I don't think that's going to work for many people.
No.
But, increasingly the sort of things that if you were really lucky and you got to the point in your career of having a personal assistant, you might have done for you, like booking travel and doing expenses and sorting out your calendar, all of those kind of things. I think you can increasingly just see those being performed by AI in a very real way.
Yeah, it's going to be interesting. And now we're both in the payment, like fintech space as well. And, Visa's announcement of their AI commerce, I think it's going to be very interesting to see who's actually going to take it up and what's the real use cases. Is it one of those things that back in the day, the smart kitchens, when the milk is empty in the fridge, then the agent can help you refill and it comes delivered to your doorstep. But also to your point, like the guardrails around it. And how do we make sure that it is an agent and we can identify that versus a human being and so on. So I just find that space very intriguing.
Yeah. And I mean, you think about the fraud calls that you get, right, from your credit card company where they're like, hey, so it looks a little weird on your account. Did you buy this in Lima yesterday?
Yeah.
And the answer now is like, no, I was in Amsterdam yesterday. I definitely wasn't in Lima. Yeah. What if you don't know what your AI agents have bought on your behalf? How are you going to respond in that moment where Amex calls you up or Visa or MasterCard or whoever, brings you up and says, is this real? Is this legit or not? I think it makes it a really interesting world to design against fraud, to design against security risks and issues, to make these good experiences for people still is quite challenging and super interesting.
I wanted to go back a little bit to your point earlier about this concept of like you would be cleaning up after all the AI code. And also like, when we're looking at MVPs and you have a lot of tools out there where you can, to your point, you can ship a lot of stuff. And at the surface, yes, it works for an MVP, but when you get deeper in, not so much. What do you think this concept of speed and urgency in a way means for builders and developers, also in terms of their, I guess, like what it means for the craftsmanship?
Yeah, I actually think it's going to increase our craftsmanship because I think we're going to do a lot less of the work which is throwaway.
Yeah.
I think you're not going to need an engineer to build your proof of concept or your MVP idea or your initial product thought, right? You're going to be able to put something in front of customers that kind of works so much faster than you used to. And you might not even need an engineer for that anymore. And that's a fantastic situation to be in as a non-technical founder or a product manager or a designer. You can do a lot. But at the point that you want it to work at scale, securely, accessibly, resiliently, all of these other sort of non-functional requirements as they're very unsexily known. One of the things that I find super interesting at the moment is a lot of the work that entry-level engineers used to do is now doable by AI. But that was how they built skills, and that was how they learned what code smells, what are the things that are going to cause trouble, what's going to, you only have to be woken up at 2 a.m. for an incident a few times before you learn a lesson from that, right? Yeah. And what has changed already for entry-level engineers is that they are doing a lot less writing code and a lot more reviewing code because the AI writes the code, they review it. And the good folks deeply understand, make sure they don't put any code in that they don't fully understand, make sure that they've got good tests and all of those kind of things. But there's equally people who are just like, yeah, I mean, every time I looked into the detail, it was fine. So I'm going to trust that it's okay this time as well. And I think that's a really interesting paradigm for us. I think what we've already seen happen this year, there was this horrific statistic that 75% of entry-level roles this year are gone already for engineering. And everybody's hiring for senior and staff level engineers. But if we need senior and staff level engineers, where are they going to come from if we don't have any entry-level engineers anymore, right? And I did a presentation about this, and I'm like, do they think that senior engineers just spring from Jupiter's forehead like Minerva did? It's very, very weird to imagine that they grow on trees somehow. Yeah. But yeah, it's just super interesting that we've got this fundamental change in how people are learning, how they're developing, what kind of work they're doing. And we're not the only industry finding that, right? So, my wife's an architect. She builds hospitals rather than a technical architect or an information architect, which is what people always assume. And they had a version of this. The people who taught her how to be an architect, they used to physically draw still. They were pen and ink and pencils and technical drawings and all this kind of stuff. Her generation did everything with computer-aided design. The generation after her did everything by 3D modeling it and then just taking pictures from the side, from the top for their plans and elevations. And each of those generations has really struggled to teach the next generation because the foundations have changed so much. And I think that's what's happening for us for the first time in software engineering is we've had such a significant change that actually the way that you learned isn't going to be the way that the next generation learns. And so you're struggling with not just how to help folks with these new tools, but also how to help them learn effectively when we happen to have a sort of perfect learning environment for people in the early career. The type of work they were doing was perfect for the type of learning they needed to do. And now that's just gone. It's just fundamentally changed in this really interesting way.
And what would you, before I move on, because I wanted to also hear like what does that then mean for the managers and the CTOs, right? But before then, I'm curious, what would you advise the newcomers to do? Like, because if this is happening, because would you argue then whatever they get taught in university, that's also out of date? Like, what do they do then?
I think it's been the case that what you learn at university is out of date by the time you graduate for a while. It certainly was when I graduated. I went into work and was like, wow, quite different than what we thought, which was quite interesting. I was at a university that had tried to modernize and in the early 2000s was teaching Java because that was the language of the day in professional terms. There were definitely other universities that were not trying to modernize in that way. the foundations are still really valuable. And so I wouldn't say to somebody going to university today, like, don't study computer science. But I would say, make sure you're learning the underlying stuff, not just the surface level. Because I think it's very easy to learn how to build something, but not understand how to scale it, not understand at what point is this algorithm going to get too slow to be usable, at what point is the complexity of this approach going to be problematic. All of that stuff's really helpful. More of a distinguishing aspect between the different ways people come into the industry as well, because in the past, entry-level roles were just like, build the thing that you're asked to build.
Yeah.
And so you just needed good enough building skills that you could then learn all of the rest of it along the way as you grew. And I think now some of those foundations or those principles are a bit more important than they used to be. But also some stuff that, frankly, we're not brilliant at teaching in sciences is going to become much more important. Stuff that liberal arts are much better at, like critical thinking and appropriate skepticism and those kind of things. Ethics, we're increasingly going to need this much broader skill set in order to succeed.
I wanted to hear from the manager side and the CTO side, because of this shift, what do you foresee for yourself and your peers in the industry?
So I think what a lot of us are doing is just recognizing that the way we used to build things isn't the way that people are building things now. It's just a fundamentally different experience. And a lot of CTOs I know, myself included, we're playing with this stuff in our spare time because we can't be in a situation where we don't understand the work of our teams and we don't understand the pressures and the experience that they're having. And so I think a lot of us are building on the side or finding. David Singleton, who was the CTO at Stripe, used to do something which I always really admired. He called engineerications, where he would block out 2 weeks in his diary as if he was going on vacation. And then he would just go spend time in an engineering team for a couple of weeks and actually ship code. And he would experience firsthand what was annoying about the build system, what was difficult about the test framework. And it gave him such empathy for his engineers. I always admired that he did it and then was always like, how on earth do you make that happen in your calendar? I just don't understand how you can find that time. But maybe he's got Hermione's time turner. Maybe he's got better delegation capabilities than I have, where both could be the case. Yeah. And so I think for a lot of CTOs, it's about checking when our instincts are still right and when we need to adjust them. I think at the manager level, there's a whole different challenge, which is how do they need to use AI themselves in their day-to-day, Are they still writing reviews for people directly, or are they mostly summarizing with AI now? What are the ways that AI can help with that more management work without making it soulless? Because I don't think if I'm receiving a review, it feeling like it was written by ChatGPT doesn't feel very personal, doesn't feel very tailored to me, doesn't feel very, right? But equally, when you're trying to synthesize feedback from 15 different people and make it make sense for somebody in their development plan, some summarization help would be useful. And so I think there's some interesting challenges in like, how do we use these tools ourselves for non-technical work?
Now we talked about AI, Gen AI and agentic AI, and we could keep going, I feel like. But what would you say from a software development perspective? What has been, in the hindsight, the biggest takeaway or learning or something that's worth paying attention to?
I think the biggest thing is that you're less single-threaded coding now and more, I think people who are really getting the benefit from Gen AI are treating AI like an army of interns or an army of junior engineers or similar. And I think it's actually more like it's a way of outsourcing your brain or getting your working memory into a number of different places. And so you can start to solve this part of the problem and send something off to investigate or to write a proposal or to write a first draft. And then you can go, okay, and trusting that that's going to come, what's the next thing? What's the next thing? What's the next thing? And this almost parallelization of work, I think, is the most interesting thing that's happened in recent years. Because I think the people who have really, really adopted Gen AI for coding purposes, they are treating themselves as a conductor of an orchestra rather than a player of an instrument anymore. Yeah. And I think that's the fundamental change that is really interesting for people. But you're kind of also you get back the track recording of the guitar and go, oof, it's a bit out of tune, let me fix that. And then you do the same for the drums, and you do the, so it's not a perfect analogy, but I think that that's what we're starting to see is the people who can marshal multiple processes in parallel do very well. I actually think some of it, I've got ADHD and autism, so I'm ADHD. I think people like me whose brains work in that way anyway, where we do lots of things in parallel, we're always thinking on multiple topics. I think we're doing particularly well in this current evolution.
Yeah. And it's interesting because you said it earlier as well, in terms of it also now opens up for the even more of an importance of having critical thinking and be skeptical towards what you see, and don't just take it for granted and suddenly become lazy.
Yeah, and I think there's some interesting studies around that going around, right? About whether, people's, in the same way that we've gotten terrible at reading maps because we've got sat-nav now and we've had GPS for so long, what other capabilities are we going to lose, and will it matter? Because fundamentally, when you're on a planet that's surrounded by satellites, the times that you really need to read a map are not very common.
No, exactly. And one of the things I wanted to ask about, because we were talking about this concept of being able to ship fast and the benefits of it, I wonder, because of working with LLMs and your future job of cleaning up the messy code, what some of the pitfalls you think builders should be aware of as they are embracing all of this new stuff?
I think that hallucinations are a feature, not a bug of LLMs, is probably the most important one. People think that that's because people are used to, I think it's called the calculator phenomenon, where we're so used to computers getting things right, we assume that they are doing things in a logical way and they're coming to the correct answer. With AI, it's a probability. It's not a hard truth or falsity. It's an actual, well, what are the chances, right? And I think that the people who I respect the most who are building with AI in a really positive way, people like Lawrence at Incident.io and his team, they are adapting to it being non-deterministic, just fascinating way. So the way you build when you have a probability of a right answer rather than a guarantee of one is really, really different. And I think that's changing the craft, and it's changing the way that people engage with the technology. I also think that we'll probably see a lot of companies start without engineers, get to a certain level of traction, and then have to rebuild things very rapidly. And so that kind of treating the first one as one to throw away and learn from is going to be increasingly important. But then I think it's actually a mistake to wait until you have to build the right thing the right way to have engineers involved, because like you said earlier, they're immensely creative. And if you involve them in the problem understanding and the ideation and everything else, then you can get to some amazing outcomes that you might not have thought of yourself, because they understand fully the problem and what's possible. And I think that's going to be really interesting to make sure that we do more of.
We mentioned it earlier, but I think it's quite important also to just touch upon, and it's the ethics. What's your take on this? Because again, with everything we've talked about, what does ethics mean and how does it play a role?
I think this is a question for the ages. It's a really big question. I think we are living in the modern reality of just because you can doesn't mean you should. And I think that's the role that ethics has to play, is to stop people doing things that are wrong, even if they're easy, even if they're expedient, even if they're going to get you somewhere faster. When I was at university, there was someone who scraped every email address of the entire student population off the university website and then sold it to a recruitment company.
Oh, wow.
And it technically wasn't against any rules at the university because nobody had imagined that you could do that yet. But it was absolutely unethical. And in modern day with GDPR and everything else, it would absolutely be a massive problem, right? But I think that was a really interesting case study for us in my degree, because all of us could have done that. We all had the technical capability to do it. Some of the people I knew were like, oh, I wish I'd thought of that first. And some of us were appalled and talking about, how unethical it was. I actually think there was far too little of that kind of consideration in our degree. There was far too little about what was okay to do and not okay to do. If you can't rely on an industry to be ethical, then you end up relying on regulation. to stop what is not okay. That's a difference we see in Europe versus the US, for instance, where Europe is much more likely to regulate, much more likely to try and protect citizens' privacy and try to protect citizens' lives than some other countries are. And then there's this huge debate about whether that's holding us back as a area of the world and whether it's a problem or not. I think having better conversations about what is right and appropriate to do is important, but we're not well equipped for those conversations and those questions, except in really, really blatantly obvious. As soon as it gets to a gray area, we really struggle to have these conversations in a productive way.
Yeah. And I find it personally super interesting why it is that we almost need mom and dad to tell us off. Like, why is it that we have regulators to tell when something is like, oh, we should actually probably not do that? I'm not sure I understand why the industry and why we just like have to get to that point where we just wait for someone to tell us off instead of, to your point, just ask yourself, does this make sense? Do you need it? Is it the right thing to do? I wanted to ask you, because as we are talking about innovation and the possibilities of the change in software development, legacy systems and technical debt.
Yes.
That doesn't go away just because new things happen. Or what's your take on that? Like, what's going to happen?
I think we're going to see some really interesting rebuilds. I think a lot of people are going to go, hey, is it actually better to just start over, understanding what we understand now, and try to rebuild with AI? And I think we're going to have a couple of really, or not a couple, I think we're going to have hundreds of really interesting case studies of whether that's viable or not. I think we're going to get some really interesting debate in the industry about whether starting AI first gives you a massive advantage or not, or whether it just gives you new problems at a different point. I think it might be the case. And I think that when we talk about tech debt, there's two useful things to say. One is, it's a lot like financial debt. It is not evil in and of itself. Like, doing something faster in order to get it in front of customers, in order to learn from it, it doesn't matter if it's scrappy. It doesn't matter if it's scalable. It might not even matter if it's accessible if you can test with a small enough set of customers, or you don't have a particular type of user in mind, or whatever else. Although I would argue you should always build for accessibility, but that's a separate argument. But like, going into debt is not inherently evil. The problem comes, like with financial debt, if you're putting the mortgage on the credit card, that's worrying.
Yeah.
How bad is the interest? How difficult are the repayments to make? That's the kind of conversation you should have around tech debt. And I think the other thing that's useful to talk about with tech debt is that there's sort of three flavors of it. There's complexity, so things that make it hard to understand the code and change it and add to it. There's fragility, so feeling like if you change it, it will break. And then there's, the right word has just gone out of my head. But, essentially you make tech debt better either by adding tests so that you can make it less fragile, by adding documentation so you can make it more understandable and easier to get into flow. And so that sort of complexity, understandability, and testability are the three things that you care about. And I don't think that goes away with AI. You still have to test things, you still have to understand them, and you still have to be able to change them and extend them. One of the things that's really interesting with AI is that, the theory is that you just keep adding to your spec and you generate the software from scratch every time. And I think people are very soon going to realize that, like, trying to do it that way, it is not necessarily going to be successful, that you have to keep building on top of something rather than regenerating from scratch every single time. And then those three things continue to be important, right? And so you can still have tech debt if any of those three aspects are affected. Some of them will evolve. Some of them will do what's called the strangler pattern, where they basically go make the interfaces really clear, so make the APIs standard, and then slowly change every part of the system that's behind the API. So you strangle away the old piece and replace it and replace it and replace it. Some places are going to modernize. Some are going to get replaced, either by the company themselves starting over and using everything they know to try and build, and hoping they can do it fast enough to keep ahead of the competition, which is obviously the risk. And that's the big problem with big tech debt projects, is if you let your interest payments get so high that you have to spend years fixing it, then those years are time when you could fall behind. And that's a really big issue and a really big problem.
Yeah.
And so I think that we'll have a bunch of legacy systems replaced, as I say, a bunch of them will be modernized. A bunch of them might live on. You know, we underestimate how many old systems are kicking around. A lot of the coverage comes on new things. But, you know, I started my career and I worked on a system called Cosmos that was older than I was. I say sometimes I've worked on systems so old they weren't legacy, they were vintage, you know, all the way over into being cool again. And, you know, that's the reality of this industry. There are people I know who makes their living by writing ever more efficient compilers for COBOL and Fortran, because there's so much COBOL and Fortran code still existing in the world, even though people haven't been actively writing that for 30, 40, 50 years. Like those are old languages, right? There are still people that if they can make that Fortran program run 10% faster, that's worth a huge amount to a bank or some other company that's got these old systems running. And so I think that we either are going to get to a point where software is really a commodity and you throw it away all the time, you build it all the time, you throw it away all the time, it becomes very easy to replace. Or we're going to continue in the world that we live in today, which is actually the more complex a system gets, the more difficult it is to replace it. And so it becomes very difficult to justify spending all that time and money rewriting something to be more modern unless there's real other benefits.
Yeah.
And so I think you'll end up with lots of legacy systems sort of on life support. And the person who can crack how to understand an existing system and have AI recreate it accurately in a better way that's less tech debt, that's going to be a hell of a business. That's going to be super fascinating to see.
That's a really good point. Especially in the banking space, I think that's definitely where everyone knows there's a lot of, legacies are a bad word to use, but
it's true.
That is what it is.
Legacy is the stuff that's delivering the value.
Yeah.
Code doesn't deliver value until it's in production. Operating is the part that delivers value. So you need your code running for it to be valuable. So all legacy contains business value because it wouldn't have survived as a system if it didn't.
That's a very good point. I will use that next time someone is saying, oh, we can't talk about it being legacy. It's like, actually, it's a really good, it's a powerful term. I wanted to start wrapping us up. What would you say folks, whether that's engineers or CTOs, what would you say they should be preparing themselves for that might surprise them?
I think this change that building becomes less about individually making things and more marshalling a load of different agents to achieve something, I think that's the biggest mindset change I think we have to have. So you're thinking less about how can I code this and more about how can I break this problem up so that it can be coded. And then I have enough understanding and enough knowledge that I can then check the code, adjust it, fix it, make it viable, and then use it. I think that's the big change coming for engineers. I think the big change coming for managers is how do we continue to help our people when they are learning in a very different way than we did? Their careers are going to develop in quite different ways than we did. And I think that's always been a risk for a technology leader and manager. The longer you've been away from being hands on the keyboard, the harder it is. The more you've got to work hard to stay up to date, to understand what the latest advances are, to understand what the latest technologies and frameworks are. I think there is going to be this postponement of how early in a company's life cycle you have engineers. I think you're going to see lots of companies start up, have somebody who understands the problem really well, try to vibe code their way to a solution, but they won't know all the stuff about what good usability looks like and how to make things accessible and how to make them resilient and all of this other stuff, right? And so I think that you'll have it continue to happen that companies suddenly want somebody quite senior to come and fix things when quite senior engineers are quite expensive. They're quite difficult to afford, and they can be a little double-edged, right? That you want to find the type of engineer who really cares about the customer and the customer problem, and wants to have cares about the outcome more than the output. we're an industry of hobbyists. A lot of us are in it for the tech's sake.
Yeah.
And that's the risk of hobbyists, is that we care so much about the technology and what it's capable of, we lose sight of the business goals or the survival of the business even, and those kind of things. And so I think that's the other thing that's going to change. We're going to have this different moment when engineering gets involved. There's a different point when you need a CTO. There's a different point when you need to have this capability. But then managing that capability is also really important, so that you don't end up with the answer from everybody being, well, you vibe coded it, so now I need 6 years to rebuild it, right? That's not going to work for anyone.
As we're coming to the end, kind of your last reflection, because as we now gone through everything, reflected back on the past 25 years and also what's happening right now and how has this changed and evolved, do you think there's a need for rewiring anything in order for us to make sure that the craftsmanship of building thrives over the next couple of years?
Yes, I think that we have to learn how to teach better, because I think that knowing how to do it yourself and knowing how to teach it well are different. But when you can teach something, you know it really, really well, right?
Yeah.
So that's the upside. I think we need to learn to teach better. I think we need to teach different things. And I think we need to have more of these ethical conversations that we were talking about earlier, about what's right as well as what's possible. Because increasingly anything is possible. And we used to joke that we were like mechanics. We'd be like, I can build it for you, but it's going to cost you, or it's going to take time, or, we were always that, the stereotype of the mechanic just sort of going like,
Yes.
oh, this is going to be an expensive fix kind of thing.
Yes.
And a lot of software engineers, we have that reputation. Anything is technically possible. It's just about how much time and effort and money it's going to take, right?
Yeah.
But I do think that there's just going to be a need for us to be a bit better at deeply understanding the business much earlier than we used to. I think there's this change in how you're orchestrating work rather than doing it yourself. I think there's a change in how close you need to be to the business and the understanding of the problem and the understanding of the user. I don't think it's viable to be an engineer anymore who just takes a ticket, codes it. I think you have to be understanding the user. You have to be understanding the product side. You have to be contributing and being creative, because otherwise, how much more use are you than an AI agent?
That's a really strong point. And I think your lessons and your nuggets around cake, lobbying around, breaking down those silos and also stay curious. And I think it also the other way around, if I should be, saying it to the business folks, they equally also need to invite the engineers into the discussions. Developers and engineers are super, super creative folks, and they could do way more than just coding, as you're saying. And I think the business also need to realize that it's not just a ticket and then code.
And I think there's been, that's the other thing that's happened over the last 25 years. You had this huge rush of outsourcing and moving lots of development roles to India and Manila and San Jose, Costa Rica, and all sorts of low-cost locations. Yeah. But that's led to this very ticket or spec-driven kind of way of working. Throw it over to a different time zone and you wait for code to come back. And if that's all you are as an engineer, that's very easy to replace with AI, assuming it continues to get better. But if you are in the room helping understand the problem and coming up with a solution nobody else would have thought of, because you understand exactly what the tech's capable of and what the user needs, that's much harder to replace and much easier to defend. And so I do think we'll see an end to purist technologists who are just in it for a particular language or a particular framework, or they care most about what they build in rather than what they are building. I think we'll see an end to that style of engineer in many businesses, because it's not defensible against this incoming wave of AI. But if you're part of the creative problem solving, then that's something that's much harder to replace.
Wow. We have covered so much ground and really touched upon how our builders, hackers, and the community being rewired because of the new rules of innovation and what's coming our way, and already now forcing the software developers and those craftsmen and women to think differently. Meri, thank you so much for joining the Pantrium Rewired Miniseries. I really enjoyed our conversation.
Me too. Thank you for having me.